Alright folks, in this video we are going to take a look at the components of the CaHRtenna end-fed half-wave dipole portable antenna, and we're going to run through building this particular antenna. I do want to note that this is not entirely complete. There is some heat shrink that you put on over top of the innards, for lack of a better word, of the antenna I haven't done that because I'm still testing and playing around, and as I mentioned, this is a prototype design, so it has not been finalized, and I still need to be able to get in here and tinker around with the innards. This does include about 65 feet of wire to use as an aerial and a 17-foot counterpoise. Anyhow, I would encourage everybody to comment and share your ideas and thoughts below. In working with the folks over at Coffee and Ham Radios, myself, Chuck KK6USY at Ham Radio Adventures, Ham Radio Dude, Sean over there, and Steve at Temporarily Offline, for the folks that don't know, we do a show called Coffee and Ham Radios where we live stream every Saturday and Sunday morning at 9 Central. And we just started playing around with some ideas for a portable antenna that we wanted to build for ourselves, sharing that on some of the live streams. There was a lot of interest, so we decided to go out and get some of these components manufactured for us. And here we are. And so I wanted to share a quick prototype build. Let me know what you think, and I'll respond in the comments. Thanks, everybody. Okay, so what I want to do is I want to talk a little bit about the frame or the base of the antenna. We've made a few versions or revisions of this. This is the last prototype that we made using 3D printing. We did have to make some changes from the original design, just as you go through the process of development and testing along those lines. Once we got a design that we liked, we sent these off to a manufacturer. 3D printing is cool, and I'm not trying to upset any 3D printing enthusiast, but there were a couple of different things. One is we didn't want to have to print a bunch of these off. That was something that was just not desirable. The other one is that we played around with a lot of different materials, PLA, PLA+, ABS, PETG, and we just didn't find one that we felt was as strong as this nylon-based material that we could get manufactured for us. It has a little bit of a texture to it, but it is extremely durable and very rugged. And that's what we wanted. One of the things that we were worried about with the 3D prints is that if this got dropped on concrete or something like that, that it may crack or break. So we felt more comfortable going with the nylon design. We also felt that this would be better served for heat that may generate during the use of the antenna. So let's just talk a little bit about the frame. What we decided to do is run a series of mount points down the side. So you could use a carabiner or some string or cord to hang this in various ways. Like you could double loop a string through here and then hang it like this if you wanted to. You could anchor this down with a carabiner to a fence post, to a tree, to a spike in the ground, anything that you want. Here's the mount point for your BNC. We're using a BNC female connector where it'll come down and you can clip your coax in, and then we have some stress relief here should you choose to use it, where you can use a zip tie to go ahead and anchor your coax to the device, or you could use a zip tie across these 2 points. The main thing that we wanted to do with this design is have a ton of flexibility. We also have some built-in strain relief here, where you would feed the included wire into this hole and then thread it through, and then you would attach that to your toroidal core. For the toroidal core, we chose to use NFT 140 mix 43. 140 means the outer diameter of this toroid is 1.4 inches. We're going to be doing some more testing with it, but in our testing we were able to do 100 watt single sideband, no problem. And we were able to do digital modes. What we did test in was around the 75 watt range. We want to do some more testing and see if we can get better results at a higher wattage, around 100 watts. The design concept for this antenna is a 40/10 end-fed half-wave dipole. You can use different lengths of wire on here to build whatever you want. You could make it an 80 meter, you can make it 160 meter, but the included wire will only get you to 40 meters. And the use case for this is we wanted to have it as a portable type antenna, something that you would take out into the field, you would set up, and then you would use this antenna. It's not something that I would suggest that you use for a long-term base station or QTH or ham shack deployment. You could if you wanted to, but again, the design principles here are for a portable antenna. So when you get your kit, it's going to come with 100 feet of this 22 gauge silicon jacketed wire. And we wanted to use the silicon jacketed wire. It's not tangle free, but it's tangle less wire, and it is very flexible and very forgiving. So we liked it quite a bit. The frame is going to stay in this gray color. This wire, we can't get it in bulk unless it is in red or black. Also, it's not going to come on a wire winder because the frame itself acts as a wire winder. I just did this to make it easier during the build process. Let's take a look and see what else comes in the case. This is a lug that we would use for grounding or attaching a counterpoise if that is part of your deployment plan or strategy. And again, with the flexibility of this design, you could mount this anywhere you want. I'm going to put it here in this second hole. This particular lug is a hex screw or hex bolt with a wing nut, lock washer, and regular washer. We've also looked at this Phillips head screw. We haven't quite decided on what we're going to do here. If you have any questions, comments, or suggestions, go ahead and post them below, and we'd love to hear the feedback. There's some other things that come in the kit, so let's just take those out and talk about it. You get 2 zip ties, and these zip ties are used for anchoring your core to the frame. You would run it through the center of the core and then through this hole, and then these for each side. This is the 50 ohm female BNC connector that will go in through here. And then you have a lock washer, you have a mount point for your shield connection, and then you have this bolt. This is a capacitor, and it is a 100 picofarad, 1 kilovolt capacitor. And you use this to bridge your center conductor to your ground. The kit will also come with these bullet connectors, or terminals, as some people call them. What we've seen is that some folks will choose to run their wire through the stress relief that we talked about, and then attach this lug configuration after that. And you can do that if you're interested in using various sized aerials. One thing is that because it's an end-fed half-wave dipole for 40 meters, it will be harmonically resonant on 20, 10, and 15, which is also a harmonic of 40 meters. So you should be able to get those bands pretty easily. But in the event that somebody wants to maybe cut a 60-meter dipole and use that, they would get 60, 30, and 15 as well. So that's just part of the design. And then you also get some 16-gauge enameled copper wire, sometimes referred to as magnet wire. And then this is what we will use to wrap our toroidal core to get our 49:1 impedance transformer ratio. And lastly, in the kit, we give a piece of heat shrink. Let me see if I can dig that up real quick. Once you're done building your antenna, what we would recommend is that you take this heat shrink and then you slide it over your antenna. And then use a heat gun or a hot air gun to go ahead and shrink this down and to hold everything in place, and then also provide a layer of protection. Not 100% sure that this is the color that will be included in the kit. We're looking at various options. So anyhow, let's go ahead and get started with the build. So what I've done here is I've straightened out the 3 feet of included magnet wire. And I want to take about 6 inches of this magnet wire and I want to fold it back. So let me go ahead and measure that out real quick. Each square is a 1/2 inch, so I'm just going to go ahead and measure 6. 1, 2, 3, 4, 5, and 6. And then I'm going to go ahead and I'm going to just bend this wire. And then what I'm going to do is I'm going to use this Irwin Quick Grip because it's handy. So let me go ahead and open it up. And then I have my wire secured into the vise. Now to make twisting this, what you need to do is your first 2 wraps on this antenna are called your primary. And we want our primary to go around twice. And the magnetic wire needs to be twisted for that. So once you have this in your vise, you can use anything for twisting. And I'm going to go ahead and I'm going to use this happy pencil that I have here that talks about true love. So I'm just going to slide that in. And then I'm going to go ahead and I'm just going to give it some twists. So here I have my twisted wire for the first 2 or primary windings. So let me go ahead and I'm going to put this into the toroid. Now I want these to be as tight and as close to the toroidal core as possible. And so what you can see here now is that I have 2 turns. Every pass through the center of the toroid is a turn. And now what I need to do for my secondary is 12 more windings. So I'll have a total of 14 windings, 2 on the primary, 12 on the secondary. When working with wire that is rigid like this, you want to be extremely careful. We are going to wrap 7 windings and then we are going to cross on the 8th. So let's go ahead and do that now. So here I have 7 windings, and what I want to do is I want to go ahead and I want to do the 8th, which goes across and under. So let's do that now. Okay, so we've wrapped our toroidal core, and I want to move these around a little bit and make sure that my spacing is somewhat consistent. So we have our 2 primary turns, and then I have 1, 2, 3, 4, 5, 6 on the crossover, 7, 8, 9, 10, 11, 12. For a total of 14 turns. Now this will get mounted to the frame like so. I'm going to go ahead and I'm going to clean these up just a little bit. I want to be careful not to mark or damage the toroid when I do this. Okay, so now we are going to mount our BNC connector. You always want to come in through the bottom on this BNC connector. That way you're ensured that you will get a good connection with your coaxial cable. Also, if you take a look at this BNC connector, you will see that there's a little bit of a cutout here on the center conductor. And what I want to do is I want to make sure that that cutout is facing up. That will make the job of soldering the toroidal core to this connector much easier. So what I'm going to do now is I'm going to go ahead and I'm going to put on the lock washer. And then I'm going to go ahead and put on my connector for my shield connection or ground. And then I'm going to tighten this bolt. Now, one of the things that you can do is you can put a little Loctite or even nail polish on here. So once you have this tight, you know it's secure and it is not going to go anywhere. Okay, now I want to get an idea of placement for my toroidal core, which is going to go here on this prototype. So what I need to do now is I need to cut some of this off. I want to be very careful when I do that because I don't want to have to rewrap this core. And then I'm going to strip this with a razor blade. There are a bunch of different techniques for stripping the enamel coating off of magnet wire, but I prefer to just go ahead and carefully use a razor blade so I don't cut myself to go ahead and scrape the wire bare. Also, what I'm going to need to do is I'm going to need to do the same thing in preparations for this. What I'm going to do is I'm going to cut this here, and then I'm going to size it so one piece goes through this connector and can be soldered here. And then what I've decided to do is mount the lug here, so that way I can go ahead and I can attach that as well. Okay, so what I've done is I've scraped the ends of all of these with the razor blade, as I mentioned. And then I've zip tied it down to the frame using the center hole and then these center outer holes. So my toroid is firmly in place, and then I've taken the conductor for the center pin and I put it in that slot that I mentioned earlier. And then I've taken the ground and I have it coming into this shield connector here. Now what I have here is the ground for a counterpoise or ground rod or any way that I might ground the antenna. And what I'm going to have to do is use something like this, which was not included in the kit but will be moving forward. That's why we do prototypes. And then I'm just going to go ahead and I'm going to connect that down right here. The other thing that I need to do is install a jumper. And I'd like to have a jumper from here to here on the shield connector. So what I'm going to do is I'm going to take some of this excess that I have where I connect my element, and I'm going to just go ahead and I'm going to use this to work as that jumper. So I'm going to go break out the soldering iron, and then we're going to get to work. The other thing that we're going to have to do at some point is that we take this capacitor, and then I will bridge it here from the center pin to this shield connector. All right, let me get to work. Okay, before I get to soldering, what I wanted to show is that I did take a piece of this off, and then I scraped it, and you can see it here. And I looped it around where I will be soldering this primary turn to the shield connector for the coax. And then I brought it down here to create that jumper that I spoke about, and then I sized it using the counterpoise lug. So I know exactly how far everything's going to be. What I'm going to do now is I'm going to get the solder gun out, or the solder iron, and I'm going to solder everything up. And I'm going to crimp this as well with a pair of crimps, just to make sure that I have a very solid and secure connection. Okay, now that we have everything all soldered together, one of the things I wanted to talk about was checking for continuity. So let me grab my multimeter real quick. Now what this test will do, it will allow me to make sure that my solder joints are good. So hopefully you can hear the beeping. It's not too entirely loud, but what I want to do is I want to check past the solder. So this is for the ground. So when I touch the shield over here, I should be okay. And hopefully you can hear that beeping, letting me know that that solder is good. The other one is I want to come in here and I want to touch the center conductor inside the BNC connector, and I want to touch the end of this. And then hopefully you can hear that beeping. So that tells me that the solder on the center pin is good. The solder here on this connector is good. I can actually test these two wires. Let's test both of these. And the solder down here on the lug is good, and I seem to be fine. What I need to do now is determine the approach for attaching this piece of magnet wire to the aerial. The design was to feed the aerial wire in here, come out, want it to come out the bottom of this hole here, up through the bottom of this one, and then I can go ahead and I can attach it. What I think I'm going to do is I'm going to use the other terminal lug here, and then I'm going to attach this here. And then that way I would be able to connect via another eye ring to this. So we'll show how that's going to work. I still am going to come through here for strain relief on the aerial or the antenna element itself. The other thing I wanted to mention, that when I went to put the BNC adapter into the frame, it was a really snug fit. So I took a 3/8 drill bit and I cleaned that out very slightly. It was not much needed to come out. But I think what we're going to do on the design before we send any more of these back to the manufacturer is we're going to increase the size of that BNC through hole. All right. Okay, the next step for us is going to be to connect the capacitor. And we want to connect that here in line with our center conductor. And I lightly tinned this. It's going to require some touch up here. But I lightly tinned it so it would connect easily. It's difficult doing this while looking at the computer screen as opposed to the device. And I think we're good. Okay, that probably wasn't the best camera angle or shot, so I just wanted to show that we now have our capacitor in line as well. I went ahead and I soldered that on there, pre-tinned the capacitor to make that job a little bit easier. Okay, so what I want to do now is talk a little bit about the stress relief or strain relief holes that we have in the frame. There are actually 3 of them. This one is difficult to get to. You can see the 3 of them here on the back as well. So what I think I'm going to do is put this wire here in this end piece. And then when that's there, I'm going to take something small like this, and I'm just going to try to feed it out the back. And then you can see how the wire comes through, and then I can thread it here to come out the top. And that will work as stress relief. I could have also just gone in and looped it around. I didn't need to go through the hole on the top. And then what I can do is I can prepare another lug like this, and then I can just go ahead and attach it here. When I'm done, I can go ahead and cinch this up. And that is one way to attach the element or the aerial to this device. What I think I'm going to do is I'm just going to prepare a lug for this, and then I'm going to attach it here. So let me go ahead and do that now. Okay, the first thing I'm going to do is I'm going to take about 1/2 of an inch of glue-lined heat shrink, and I'm going to put this on my wire. Then I'm going to go ahead and strip the end of the wire. Now I'm going to apply the terminal. And I have to find my crimpers. Hold on. Now we're going to add a touch of solder. My desk is getting pretty messy over here. Okay, now what I can do is I can just go ahead and I can fit this underneath of this wing nut, and I should be fine. What I need to do now is go measure about 70 feet of this wire, attach it. I'm also going to measure 17 feet for counterpoise. And then we'll take this outside, we'll mount it up, we'll hook it up to an NOVNA, and we will tune the antenna. Okay, so let's talk about some changes and some things that I've learned. We had this twisted pair that comes off of our primary, and I had one of these going down to this terminal lug. I ended up not liking that, so I snipped it and I tied it into the shield connector here. It's not the cleanest solder job, but it's functional. And we still have our jumper in place that connects this ground lug to our ground on our shield. So that makes sense. The other thing is that when I connected the aerial up to this particular spot, I had some difficulty when I wrapped wire around this. Because this is a wing nut, the wire did get tangled around here. And one of the things that we could do is we could use a T-nut. But I don't think that that is going to happen. So what I would suggest or recommend is using the built-in strain or stress relief and then connecting here. The other thing is that you could drill this hole out. You could move this terminal to here, connect it here, use the first 2 holes, this in and then this out, as your strain or stress relief, and then you could connect your aerial this way. Another option would potentially be move this connector to one of these 2 holes, and that would get it more out of the way when the wire is round. Similarly, for this ground nut or lug, I think that I would move this to this particular hole, and then that way when I run my counterpoise around here, or any excess wire from this side to this side, it would less likely get caught up or tangled into this wing nut. That is really it. And as I mentioned, this is a prototype. And we do these builds. All of us in Coffee and Ham Radios do these builds to test out different ideas, different configurations, and different concepts to make sure that when this product is ready to go to market, it is the best that it can be. So stay tuned for more updates. I'd like to thank everybody for watching. And as always, any suggestions, comments, or recommendations, go ahead and post them down below, and I'll do my best to respond. Thanks for watching, everybody.